I will show you how to use direct substitution, and also when you cannot use direct substitution to find the limit using algebra skills. So we start with part A. We learned how to state limit based on graph before or table, but in this case we just use algebra. However, I would like to double check my work, so at the end I will show you guys how to state limit based on each of the graph also, to make sure we understand both way, and we'll see that no matter what way we use, we should end up with the same answer. Alright, for part A, what does it mean by direct substitution? So when you have the limit x to 1, so you take this value and you plug it directly to this function right here. Sometimes it works, sometimes it doesn't work, and when it doesn't work, when you plug in the x value and you get 0 for denominator, that means your fraction will be undefined. That's when you cannot use direct substitution. So in this case, if you plug 1 into the x value, it works for both numerator and denominator. Therefore, it is okay to use direct substitution for this problem. So the next step, we will have 1 squared plus 2 times 1 over 1 plus 1, and we get 1 plus 2 over 2 and 3/2. So limit of x approaches to 1 for function x squared plus 2x, everything divided by x plus 1 will be 3/2 or 1.5. Okay, they are equivalent. Okay, all right, let's move on part B. So for part B, we also have x approaches to 1. So if we use 1 plug into the function, what happened is we cannot use direct substitution, because when you plug 1 into the denominator, you have 0, and that means your function will be undefined. Therefore, before we do that, we will simplify it. So next, we have limit x approaches to 1, x, and then we will factor x squared minus 1. So we should know the difference of squares, which is x plus 1 times x minus 1, and everything over x minus 1. And that allows us to simplify this part. So now we have limit x approaches to 1, x plus 1, and then we have 1 plus 1 is 2. So limit of x approaches to 1 of function x squared minus 1, everything divided by x minus 1 will be 2. Alright, and hopefully you guys see the part that after we simplify, if it's possible, we still use the direct substitution to find the limit. Alright, for part C, we have the same issue. If you plug 1 into the x value on the denominator, you will get 0. So therefore, before we do that, we need to simplify it. And this is on the denominator, you have square root x minus 1. So it's a little bit, it's a twist right here, because you will think about how you factor out the numerator in order for you to cancel the denominator part. And x minus 1, usually we don't try to use difference of squares to factor it, but in this case we can think of this, the x as square root x square, and then 1 minus 1 square. And if we do that, so we can rewrite it in different forms, x1 and then square root x square minus 1 square, and then square root x minus 1, and that allows us to factor out the top part as square root x plus 1 times square root x minus 1 and everything over square root x minus 1. And that allows us to simplify this part. So next we have limit x approaches to 1, square root x plus 1. And then we use the direct substitution now. So square root 1 plus 1 equals 2. Alright, so we keep going. D. So same issue, so therefore we need to simplify it. So we have limit x approaches to 1, x minus 1. And the bottom part, we can do it as this 4 means 2 squared. So we can do x plus 1 plus 2. And then x plus 1 minus 2. Like this. Okay, we apply difference of square formula again. And then this give us limit x approaches to 1 and then x minus 1, we simplify a little bit, so we have x plus 3 and then x minus 1. Now we simplify it, we get limit x approaches to 1 over x plus 3. We can use direct substitution now, so it's 1 plus 3, 1 over 4. Right? Okay, keep going. So you can pause here, you can try for the next 2 problems before you continue on this video to see if you understand it and you're on the right track now. So we have limit x to 1 and then x minus 1. The bottom we will try to make it as one fraction. So we have 1 over x minus 1 times x over x. That gives us limit x equals to 1, x minus 1, and then 1 minus x over x. And then we can do we can rewrite it as x minus 1 on top multiplied by reciprocal of the second fraction, which is 1 minus x, like this. And we try to make x minus 1 and 1 minus x be the same by doing a little trick here, so that we can factor out the negative. So we have limit x approaches to 1, and then we can factor out a negative sign, and we can have 1 minus x, and then x over 1 minus x. So that allows us to simplify these two. So now we have limit x approaches to 1 and negative x. And we use direct substitution now, so we have negative 1. Okay. Alright, last problem. This problem, if you plug 1 into x minus 1, that means it's give you 0, and there's no way, no other way we can use or do to simplify it. So therefore, for this problem, since we use direct substitution, we use 1 to replace the x, we have 1 over 1 minus 1. That means undefined, so therefore we don't have limit for this problem. So this one does not exist. Alright. So hopefully this problem help you understand how to state the limit value of function based on or using algebra skills. So now next I will do the graph to make sure our answer is correct. So I already put in these functions on decimals, and now I just make sure I double check it. So then the first one, part A, and we see approaches to 1. So we have approaches to 1. Okay. So we see that approach to 1 is right here. On the left side of the function, if you go toward x equals 1, the function will be right here. And if you go from the right toward x equals 1, also your function, your limit will be right here. So that will be the limit of x at 1, which is 1.5 or 3/2. And that's what we got. Okay, right. Second one. So we see limit x approaches to 1, 1 is right here, and the limit on the function will be 1. Very close, very close to 2, but never becomes 2 because we have a hole at x equals 1. But doesn't mean we don't have limit. We still have limit, which is 2. If I ask you to evaluate f of 1, then you don't have value or the output when your input equals x equals 1. But if I ask you what's the limit when x equals 1 or x approaches to 1, then we still have limit is 2 because all the value of y from both sides, left side and right side, is approaches to x equals 1. The y value get very close to 2. Even if it never becomes 2 because we have a hole at 2, but it reached very close to 2. It can be 1.99 or 2.00001. Very close to 2 from both sides. So therefore our limit for part B is 2. And next one, approaches to 1, we also have 2, and that's what we got right here. Okay, and then part D, approaches to 1, 1 is right here, and the value will be 0.025. Okay, very close to 0.025, right? And that's what we got right here, 1/4. And then for part E, approaches to 1 will be -1. Very close to -1 from both sides of the function. Okay. And then the last one, we have function like this. So when you have x approaches to 1 from the left side, you see it's go to -infinity. And when you have x approaches to 1 from the right side, we have the y value go to the positive infinity. Since they both they go to different directions, therefore we don't have limit at x equals 1. So therefore limit will be does not exist. All right. So hopefully I already give you idea about how to use algebra skills or how to evaluate limit algebraically, and just have a quick review on how to use graph too. So hopefully you guys can practice this on your own, and it help you understand this concept a little bit more.